Hey, and welcome back to the channel. Today I will show you how to solve detecting a cycle in linked list problem. This question has been mostly asked by Amazon, but it also asked by various other companies like so. We will use JavaScript and explore two major solutions. Also, I have a linked list playlist where we discover linked list problems from Leetcode that you may be interested in. I'll put a link in the description to check out. But before we continue, make sure to hit the like button, subscribe to the channel, and give me a feedback. Let me know what you think about this video. It's highly encouraged and appreciated. So without further ado, let's dive in. Okay, here is the problem. Given the head of linked list determines if the linked list has a cycle in it. There is a cycle in a linked list if there is some node in the list that can be reached again by continuously following the next pointer. Internally, pause is used to denote the index of the node that tail's next pointer is connected to. Note that pause is not passed as a parameter. Return true if there is a cycle in the linked list, otherwise return false. So let's see some examples. Here is the first example. As you can see, we have a simple linked list 3, 2, 0 and -4. But the problem with this linked list is -4 points back to node 2, which creates a cycle. And if we traverse through this linked list, we will never get out of it. Second example, it is the same 1 points to 2 and 2 points to 1, a cycle. And finally, last example, we only have one node, so it does not create any cycle. Let's see how we are going to solve it. So here's our first example. We will do an iteration over our nodes definitely, but at some point we will go into stuck in a cycle, going from 2 to 0 to -4 and start all over again. But first, let's think roughly the most brute force solution and then shape our thoughts around it. I can suggest to have an array, let's say visited array, and store every item that we visit inside of that array. And as soon as we see a duplicate element, then we know that it's a cycle. But storing values as far as we traverse nodes of linked lists and also searching whether or not we have a duplicate node seems like a big bottleneck in time and space complexity to me. So no, because we cannot go with this solution. There are basically two ways that we can approach this problem. First one is a bit naive and simpler by mutating the linked list values. Let's say, what if as far as we traverse the linked list, we change the value to something super obvious, like a capital A, and mark each node with it intentionally. Now think about this. If we have a cycle, definitely we will get back to one of the nodes that we previously changed its value, right? So if we see a node with value of A again in our traversal, it would mean that we already visited that node and cycle starts from exactly that point. Let's get into writing code for this solution. So here we are in Leetcode. This solution is going to be very easy to code. First, we need to define our current pointer for linked list traversal. So we will do let current equal to head. Then, as long as we have our current value, we will do a while loop. While current do something. After that, inside of this while loop, we will update the value and then move on to the next node. So we will do current.val equal to our super obvious capital A letter, and then current equal to current.next. But before this updation, we need to check if current value in our hand is A, because if we see a node with value of A, basically it would mean that we get back to some previously visited node that we already changed its value. So we will do in the beginning of this loop, if current.val equal to A, we found a cycle, right? Return true. And at the end, if we have passed this while loop and if we still haven't returned true, that would mean that we haven't detected a cycle in this linked list, and this is kind of safe linked list to cycle through. So we would do return false. And if I run this, everything is passing, and if I submit, we are in a good shape here. But there is a big drawback for this solution. We are already mutating our linked list, and definitely it should not be the case in real world use case if we encountered such a problem. So a big no again. Let's continue in our slides to show you a more better solution. Now for our second solution, we will going to use Floyd's cycle finding algorithm, or there's a common name for it called hare tortoise algorithm. So the idea is we will have two pointers, fast and slow pointer, initially placed at first node of given linked list. Fast one is going to be travel as double as slow one. Again, second iteration like that. Basically, in case of cycle, definitely the fast one will pass over the slow one and finish the cycle first. Meanwhile, the slow one is still trying to catch up and they will meet at some point together. But fast one is one cycle ahead then. And as you can see here, for last iteration, here's the point that both slow and fast pointer will be overlapping on each other on node -4. That's simple. Let's implement this one in code. So here again, we are in Leetcode. As I showed you in the slides, we will have two pointers, fast and slow, like this. Let slow equal to head, let fast equal to head. Then we will do a while loop as long as we have fast and it has a next value. Remember that we don't want to pass over linked list in case of a linked list without a cycle, and we always need to have a guard for it. So we will do while there is fast and fast.next is a value. Now time for updating the pointer. The slow one is going to be assigned to the next node, slow.next, and fast one is going to be moved double as slow. So we will do fast equal to fast.next. Next. Now, finally, or check if slow is equal to fast, then we will return true. As of our previous implementation, again, if we exit the while loop without finding anything, then we might return false, like that. And if we run this, tests are passing, and if we submit, everything seems to be fine. Now, let's jump into the slides to discover time and space complexities for these two solutions. For time complexity, we will have O of n for both solutions, where n is the length of our linked list because, of course, we are traversing all of the nodes. For space complexity, it will be O of 1 constant space complexity because for mutation solution, we don't do anything except changing node values. And for Floyd's cycle finding algorithm, we are just having two pointers and nothing else. And with that, I can say that was it for this video, and I'll put a link in the description regarding the linked list playlist in my channel, so make sure to check that out as well. At the end, please like, comment and subscribe to the channel, and finally, hope you enjoyed this video and stay tuned for the next one.